Alright class, today we are going to be looking at graphing systems of equations. So if you look on this first page, it is a review of graphing. Okay, so I do want you to go ahead and pause this video and graph each of these lines right here. I'm just going to go through and graph them myself. But you need to know how to graph to be able to do graphing systems of equations. So remember, if it's in slope-intercept form, y equals mx plus b, we can use the y-intercept first and then the slope to get our points. If it's in standard form, we can use the cover-up method. So go ahead, pause this video, graph these 4 lines, and you can unpause it to check your work. And I'm just going to graph them. The y-intercept is -4. Slope is 2. You go down 4, and we're going to go up 2 to the right 1 to get our points. There's our first line. Second line, I'm going to use the cover-up method. So I've got -3x equals 6. Divide both sides by -3. X will equal -2, so that's my x-intercept. And then for y, we've got 2y equals 6. My y-intercept will be 3. There are my 2 points. Graphing is easy. Okay, now we've got an x equals, remember this is vox. It's going to be a vertical line at x equals -3. And then we've got y equals, that's going to be horizontal line at y equals 2. Okay, so that should have been a review. Let's go ahead and scroll, or not, you won't have to scroll, I'll scroll down. And we need to graph each linear inequality. So remember, for linear inequalities, that means there's not an equal sign. We're going to have to shade. And then there's either a solid versus a dotted line. That's going to depend on the sign. So remember here, because we have a greater than, we're going to shade above. And it's just a greater than, it's not equal to, so this will be a dotted line. And then we're either going to use, again, slope-intercept form or that cover-up method. Here I can easily see that my y-intercept is -3 and our slope is -2. So we'll do the same thing. Go ahead, pause this again, look through these problems if you haven't already, and then check your answers. So first we're going to graph the -3, and then our slope is -2, so we're going down 2 to the right 2. You can also go up and to the left. There's our line. And then I'm going to do the cover-up method. Oh, sorry. Ignore me. This needs to be a dotted line. And we need to shade. And so we're shading above. We also want to list possible solutions. So any points in that shaded area, I'm going to say 0, 0. And I'm going to say 0, 1. But anything over here in that shaded area works. And let's graph the second one. So this is going to be a solid line, and we are shading below. We're shading below because it's less than. Solid line because it's equal to. Cover-up method, x will be less than or equal to -3. And then 3y is less than or equal to -3. Divide by 3. And our y will be -1. Solid line. Shade below. Solutions anywhere below that line. So let's use the point. I'm going to say, can it be on the line for these? Yes, it can be on the line because it is a solid line. So I'm going to use the point -3, 0, and -3, 1, -1. Those are my 2 points that I used there. Over here I used 2. Okay, and then our last question, is the point 0, -3 a part of the solution set for the inequality graph in number 5? Why or why not? So over 0, down 3. So think about, is that a solution? Our answer should be no, because there is a dotted line. You could say no, the solutions do not equal the line, anything like that. That was our graphing review. Hopefully you were able to complete those successfully. Today we are looking at solving systems of equations and inequalities by graphing. Okay, so our method is going to be graphing. That's why we just did the review. And we're going to be graphing multiple equations on one graph. Okay, so these problems, if you don't graph both lines correctly, you will get something wrong. So let's first talk about what is a system of equations. So a system of linear equations consists of two linear equations. So you're going to have two lines. The solution to the system is the point where the two lines intersect. Okay, so we're going to graph two lines. Hopefully they intersect, and if they do, that one point will be the solution. So let's look at some examples. Look at the graph shown below. What is the solution to the system? Okay, so system just means two equations, two lines. Where do they intersect? So let's see. I'm going to have this green one, my first line, purple, my second line. Where are they intersecting? Oh, at that point. That point is -2, -1. So that is our solution, -2, -1. You don't have to do all that highlighting, all that coloring, just pointing it out to you. Okay, so number 2, let's do this one just by looking at it. There's that intersection point. That point is -2, 0. That is our solution. Very, very simple, as long as we can read the graphs. Okay. The next 3 is to find each solution. So here we have some graphs. We have 2 equations of lines. We are going to have to graph each of these lines and then figure out our solution. So we have our y-axis here and our x-axis. We're going to graph these. So I'm going to graph this first one in a hot pink color. Okay, so I'm going to use the cover-up method. My 2 equations, I would have x equals 3, and then I would have y equals 3. If I just cover up my other variables. So we're going to go up 3, over 3. There's my first line. Then for the second one, let's do that one. I'll do that one in orange. If we use the cover-up method again, you would have y equals -6. That's easy. 1, 2, 3, 4, 5, 6. And then our second one, -2x equals -6. Divide those by -2, and x will equal 3. Interesting. You will connect those two. Where are they intersecting? Right there, that point is 3, 0. Okay, so here's where your graphing lines comes into play. You have to either know cover-up method or slope-intercept method, or think about horizontal and vertical lines. So that first one, we use the cover-up method. Alright? Number 4, looking at these, think about what method do we want to use. Are we going to use cover-up method because we're in standard form, or are we going to look at the slope and the intercept because we are in slope-intercept form? Hopefully you said slope-intercept form, so I see y equals mx plus b, both of these equations. So our first one, I'll do it in green. The y-intercept, the b is going to be -2. The slope is a -1. I'm going down 1 to the right 1, down 1 to the right 1. There are my slopes. We only really need 2 points. Make sure you're using a ruler for these. There's our first line. Second line I'm going to do in pink. Here the y-intercept is 3, and our slope is 2/3. So we're starting at 3. We're going to go up 2 to the right 3. You can also go down 2 to the left 3. We have our intersection. Name the point where they're intersecting. That is the point -3, 1. We're just going to keep doing that same thing. Graph your two equations, see where they intersect. Next we have y equals 4, so that's horizontal line at y equals 4. Okay, second equation, we have y equals 2x plus 2. I know that's in slope-intercept. My intercept is 2. My slope is -2. So we go up 2, then down 2 to the right 1, down 2 to the right 1. You can go up 2 to the left. And then looking at my two graphs, they are intersecting at this point. That is the point -1, 4. Okay, so if you're struggling with graphing, you can always slow me down, pause me, rewind, if you need to look back and see what I graphed. Also go back and look at your old notes. Alright? Graphing linear equations. Okay, on to the next page. We do have some special cases. So what happens if the lines never cross? So last unit we learned that when lines never cross, they are parallel. You have parallel lines. Also a side note, the slopes are the same. Okay, so the solution when we have parallel lines, if the lines are never intersecting, there's going to be no solution. So if they do not intersect, no solution. On the other hand, it says what happens if the lines are on top of each other? In that case, you will have the same line. So these are the same line, overlapping lines. So that means that our solution, this is going to be infinitely many solutions. Okay, you can also, instead of writing the word infinitely, you can use the infinite sign if you would like. But if you think about it, if we have two lines on top of each other, so if we have this pink line, and then let's say we had a maroon line right on top of it, every single point on the pink line is also on that maroon line. So every single point will be a solution, and lines going forever and ever in both directions, so there's not an end to how many answers there are. So infinitely many solutions whenever they are overlapping. Okay, so I'm guessing, let's graph these two. We'll probably have an example of no solution and an example of infinitely many solutions. So looking at 6, I'm going to use the cover-up method. So we would have 2x equals 4, which leaves us with x equals 2. And then we'd have negative y equals 4, so y equals negative 4. I'm going to graph that guy. And then we have 6x. I'm going to change the color. 6x equals negative 9. So divide that by 6. This will give us a weird number. X equals negative 3 halves. So that's just negative 1 1/2. So x, we're going to go negative 1 1/2. That's really fine. And then negative 3y equals negative 9. Divide by the negative 3. Y will equal 3.